Hi, my name is Ramon, and alongside David and Samuel today, we'll be demonstrating how AC generators work and produce power. AC generators are often used in homes. The goal of AC generators is to use mechanical energy to produce an induced electromotive force, or EMF, in current. In real systems, the energy will be produced by something such as a turbine to turn the solenoids and produce electricity. So let's demonstrate how this works.
Okay, so now that you've heard a little bit about AC generators, I want to talk about our specific experiment. For our setup, we rotated two magnets that have that are facing out with a north and south pole inside of a solenoid. Faraday's law states that if you affect the rate of change and a solenoid is there to experience it, that you should induce an EMF. So we turned about 1,500 turns for our solenoid, and then in the center of it, we spun a magnet with the drill, and at around 500 rotations per minute, we were getting 150 millivolts. So for our specific case, if you wanted to make this a DC generator instead, you would have to use a commutator. A commutator is very hard to achieve practically because there are a lot of limitations to how efficiently it'll actually work. And so we decided against trying to do that. But we did try and see what the maximum number of turns was. And so for our thin copper wire, at least physically, it'll start to pop. The wires will start to pop if you get anywhere higher than like 3,000 turns, close to that. So there is like a physical limitation on how many turns we can have in our solenoid. And the reason I mention this is because the turns in the solenoid are proportionally affect the EMF. So the other thing that you might be asking is, all right, so what if we made the magnetic field stronger? But that actually kind of ties into one of the most important aspects, which is the reluctance of the air gap. This distance between the magnets and the solenoid has to be in terms of millimeters. Any larger and the magnetic field will fall away very quickly, and you won't get an induced EMF at all, or it'll be so small that you can't read it. So now Sam will finish off the presentation. On the inside of the solenoid, on this rod, are these two magnets. It should create a north and south pole, and as we spin it, it'll induce an EMF. Finally, this is our setup, and there's a couple of things here just to keep it in place, but you'll see that the two leads are connected here. And so as the drill spins faster, we'll increase the induced EMF. You'll observe that here.
We have been able to demonstrate how voltages are produced in AC machines. However, we face a lot of challenges which make our model quite different from practical AC machines. In AC machines, the design is a bit complicated. It starts from the design of the magnetic circuits. That is selection of the right material for the core of the machines. The core must be highly permeable. Again, in practical AC machines, it's usually three-phase, and the windings in the stator are distributed along the circumference, the interior of the stator, to ensure that the output is three-phase, and each phase is 120 degrees, 120 degrees away from each other. Again, the air gap between the stator and the rotor poles are in orders of millimeters, and that was quite impossible to achieve in our project. In a practical AC machine, we found out that the magnetic field is produced by electromagnets. Electromagnets ensure that we have high magnetic field in the core of the machine. Besides all these challenges, we've been able to demonstrate how voltage are generated, or how electricity is generated in AC machines. We found out that it depends on the speed of the rotation of the machine and the strength of the magnetic field.